welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge.
Welcome everyone to the House of ZK Radio. We are tuned in with our guests today, Varun, co-founder of Hashflow, and Thibault, co-founder of Hibachi. Today, we'll be talking more about Hashflow and how it uses ZK to essentially enhance exchange activities and for the ZK using ZK proofs for that. So I guess Varun, can you get us started with an introduction?
Oh, absolutely. So, Hashflow, like you said, we introduced a new product recently. We called it the XOS or Exchange OS. The idea behind that is to allow any exchange to prove its order book and therefore its solvency and integrity on chain. Right. So, because the current paradigm has been, obviously, I guess the previous paradigm was run a centralized exchange for performance and user experience, right? So, and then we introduced DEXs, which is basically saying put everything on chain. And both of those are two extreme ends of the spectrum, right? So what we're suggesting is you don't need to build a full on-chain order book because there are issues with that, including user transaction data being public, it being slow, not being performant enough, right? And also the UX itself being slightly cumbersome. And then if you go the centralized exchange route, then you've got attacks like FTX and most recently Bybit, although Bybit was more of a Gnosis thing, so that's can't really blame them for that. But FTX, Mt. Gox, those are good examples, right? So what we're suggesting here is we could allow anyone to just build a centralized exchange that is built for performance and user experience, but they just need to prove their solvency on chain using mathematical proofs or ZK proofs, and that guarantees that the exchange integrity is preserved. And in a world where if you suspect any funny activity behind the scenes, that allows any user to exit from the exchange without their permission. And that, I think, allows you to achieve the dream of ZK or decentralization even that you want to accomplish, right? So that's what XOS has been designed to do. It's an infra that allows any exchange to prove its transactions on chain. And then obviously we have Hibachi, which Thibault will talk about, which is the application where you get to see this magic in real time. You get to feel it. We've been saying ZK has been this research breakthrough that is not quite production ready, but I think we are finally there where you can actually see real world applications that are already being transformed using ZK, and Hibachi is one of those things. But you can finally see how this plays out in action in real world, right? So we'll talk about these things, obviously, but that's a brief intro to all these things.
Amazing. Thank you, Varun. And I guess, Thibault, can you give a brief introduction as well?
Yeah, that's really good context. I think I'm just really excited to kind of showcase ZK in action. Already we're seeing kind of the value of combining all of that tech that people have been working for and towards for many years now. And I think the balance between having all of the benefits of running a fast order book, in a traditional centralized manner, and then using ZK to batch everything and making it provable, and having that layer of solvency security is really interesting. There's no question, we can all agree, I think, that trading is one of the main components of our industry, probably the most product market fit that we've seen so far, for better or for worse. So exchanges are at the core of what we do and of who we are. So it's important to always keep innovating within that space because we all rely on exchanges. And unfortunately, like Varun has said, our history has not been the best in terms of our exchanges and kind of how we've designed them. It's interesting, right? Because you think about conceptually the value of cryptocurrency and blockchain and kind of why we're here. And I think, at least for me, one of the main things that initially got me excited about this space was that trustlessness, right? That kind of ability to not have to trust another or an institution. But I think it's taken us quite some time to get there because we essentially just went from trusting one institution to another. And as much as we like DeFi, and DeFi is amazing for that very reason, that you don't have to trust anybody, right? It's just not performant enough. So we've kind of always been navigating between these two worlds where it's either this or it's either that, and there's always been a trade-off. But now we're here, and really, I think ZK was that breakthrough, even at the application level, that allowed us to look and then be like, wait, we can actually build an exchange here that has everything that you could ever need as an end user. So yeah, it's a very exciting time for us, and I'm super excited to dive into it more.
Awesome. I'm glad for the introduction and essentially describing like the problem space where it was mentioned like FTX, like the proof of funds is very, very important. So I guess the segue to this is you talk about trust. Why should we trust you? Let's say like I know you're adopting ZK.
Yeah.
How are you using ZK to facilitate that transparency?
Yeah. Well, the whole thing is that you don't have to. So Varun I think has a really good understanding of this one. But at the core, you shouldn't have to trust. Yeah.
Yep, like what Thibault said, you shouldn't have to trust anybody, right? So if you think about it, like historically speaking, like technology has always been about removing trust from the equation, right? So if you go about transistor, right, it essentially replaced unreliable mechanical switches, giving us the compute as we know it. Like if you think about TCP/IP, it replaced centralized gatekeepers, making the internet unstoppable essentially. Right, then you've got cloud computing, which basically abstracted infrastructure, right, and made computing scalable and accessible to anybody. And then you obviously had the iPhone, which put all this computation in our pockets, making it an extension of ourselves. So really, if you look at any of these technological breakthroughs, it was always about removing friction by replacing human discretion with deterministic systems, systems that simply work without needing to trust anybody, right? So, and ZK and provable computing, as we call it, right? So we think this is the next evolution where it's going to be the foundation for what's next, right? It's going to be your next breakthrough since the TCP/IP, the transistors, and so on. So in this case, what we're saying is you don't trust us, you just verify using ZK math that the exchange is solvent, meaning it has enough in its reserves to meet its liabilities. And you don't have to take our word for it. You just go check the code and you can just verify it. Anybody can do it if they want to.
Amazing. And can you go into like a little bit on how that process works? Like how do I, as an exchange, verify that I have those funds?
Yeah, so I think one of the things I want to touch base here is people generally use the term proof of reserves, but what I'd like to say is, proof of reserves by itself is not sufficient, because when you say proof of reserves, all you're saying is the exchange has enough money, right? But to do what? Like essentially, is it sufficient to meet all its liabilities? Because if that's not true, then I can say I own $10 billion, great, but if I owe people like 20 billion, then that 10 billion does nothing to me, right? So what you also need to know is that the exchange is solvent, meaning the money that it owes to its traders, users, is essentially less than or equal to the balance it has in its balance sheets, right? So otherwise it's not solvent. And in this case, that's basically what you're trying to prove. And the way you're doing this is you run the central limit order book, as the name suggests, in the most centralized way possible. Don't need to decentralize that, right? So you build that for performance. You build that for user experience, right? You don't need to mess with it. But what you're doing, though, is you're taking batch of these transactions and then using that as an input data to compute a zero-knowledge proof. And that proof is then posted on the relevant smart contracts on the relevant chains where you accept user deposits, right? So if you're using, let's say, Solana, Base, Ethereum, right? That's where user deposits are coming from. Then you're essentially posting a state without sharing the input data on those chains. that, and anyone can basically use that to have mathematical guarantees that this computation did in fact occur the way, the exchange said, without needing to look at every computation or running the computation on your own, right? So that's the general idea here, is that you run a central limit order book, you compute ZK proof on all transactions to reflect the right state updates of user balance trees, and then those balance trees and sit on a public DA. Although we're working on a privacy solution there to make sure that the data that sits on DAs is encrypted, so at any given time the user privacy is preserved. Like you're still able to verify that the inputs lead to the correct proof without the inputs disclosing user balances at any given time, right? So you're essentially offering privacy, you're guaranteeing performance, and then obviously you're making sure that the exchange is solvent.
Amazing. I love the direction towards the transparency through and verifiability, as well as the privacy preserving aspects as well. I guess to follow up with that, in terms of this Exchange OS. So I know that there's an implementation for it, like Hibachi, one of those implementations. Can you tell me more about what Hibachi implements within Exchange OS and how it's solving this problem?
Yeah, absolutely. I think at the core, it's just our foundation. Exchange OS powers Hibachi, and it allows us to run the central limit, order book. So it's funny because we're talking right now about Exchange OS and about the ZK components of all that. But really what matters to us as an application is like, what does that unlock for the user, right? Because in theory, everything is, it looks really good, but we have to care about the end user and that experience. So again, I think for us, it's a blessing to have Exchange OS because it means that we can work on all the things that make an exchange a good exchange, right? We can focus on having the right inventory, making sure that we're able to list markets well and quickly and with good liquidity, etc. That's obviously what an exchange is at the end of the day, right? We're a marketplace, and that's at the core of who we are. I think Exchange OS allows us to be essentially unlocks our ability to offer an amazing trading experience for the end user.
Amazing. So, I guess tell me more about the idea of I guess it's a mix between we have a centralized place for performance, right? Is the goal to have the best trading performance, the best liquidity? Like what is the goal that Hibachi is meant to achieve and to establish, let's say, like a differentiator between traditional exchanges? Maybe there's Matcha, which is like a decentralized order book, and then you have like other like AMMs that are there. Like where would the priority, the focus for Hibachi be in terms of other exchanges?
Yeah, I mean, the combination of what we've built means that we can have we can offer the best trading experience in all of DeFi, pretty much, right? Decentralization, like Varun was saying earlier, the end user, if you think about like the real user, like who's wants to trade, they don't care about whether your order book is decentralized or not. They just want to trade, right? And they want to do it in a way that's safe and that's fast, and they want to make sure that they have, that they have the assets that they are looking for. So for us, the main point of focus is less so about, decentralized or centralized here and all of this. It's like, here is actually the best trading experience that we can offer. And speed is an interesting kind of metric here for us, right? Because we're very competitive when it comes to speed, for that same very reason that physics allows us to be that way, because we're not fighting kind of against physics to try to maintain all these different decentralization components at the order book level, right? We get there, which is amazing, right? Because you still get all the benefits, but you don't have to kind of struggle at like 200 millisecond, or even, people fight to get to like sub-second latency, and we're right there with your with your centralized exchange. So people who are sophisticated, that more like professional trader, they care about speed. It's known, like you want to be able to get in and out of positions really quickly and make sure that you're not lagging. So I think for us, the main point of focus is to communicate that here's an amazing trading experience, and here's that proof of solvency that you also care about, right? So it's that, again, it's going back to that mean reversion. I think the history is, again, it's really cool to see, because you start with the centralized exchange, then we decentralized everything, and we're like, okay, cool. Like now this is a decentralized exchange, but it's super slow and it's kind of clunky, and there are all these different things that don't really work that well. And then now I think we're getting back to that mean reversion a little bit, and ZK again allows us to do so.
Yeah. And I guess as a summary, you're taking aspects where people care about the most is the proof of reserves, making sure that the money is there, that you're operating within those bounds, and then as a result, you can focus on enhancing the UX, the experience, and then essentially focusing on the limitations that are present within the decentralized, fully decentralized systems in relation to this. So I guess in how you see, let's say, the end game of this technology going. Like I know you're pursuing more of the UX for traders. What specifically are you looking at to make that experience even better? And then where do you see some of the main limitations in the space that you're trying to solve with this?
For sure. Yeah, I mean, I think the one thing is markets, for sure. We've gotten in this era of the market cycles being extremely fast, right? Especially when you look at this last meme coin cycle that we had. You see an asset go from like inception to essentially death within the span of 10 minutes. So it's crazy. It's unbelievable to conceive that, and so you can probably imagine from the point of view of an exchange, you're like, wait, how do we manage that, right? Being especially on the perpetual side, because you're actually trading a derivative of that asset, right? So spot is easy in the sense because you can just create a pool and then you can trade on that pool. For us, we need to offer a derivative asset with leverage, etc. So it gets a little bit more complicated. So I think the improvements that are coming on our side of things is on the listing side, on the market side. But even the other thing that I would say is there are so many people working on the infra side of things as well. So we're blessed to kind of have the Hashflow side there, the risk zero side there. Anybody who's also kind of been helping out on all the ZK improvements, because we essentially incorporate those and adopt them as quickly as we can. And we've already seen in the span of like the last 6 months, our approval costs go down and the speeds go, get only better and better. So I'm excited to kind of see what other people are going to be building, and then I'm excited to bring that into the exchange and only make it faster, stronger, and better over time. So yeah, Varun, actually, you.
No, I think that's really what it is, right? At the end of the day, users care about performance and liquidity, right? Liquidity is the king. If you don't have liquid assets sitting on the exchange, no one is going to use it. So basically, I think from an application point of view, I want Hibachi or any application to focus on the things that matter for the users, right? So on the other hand, like security should just be built in. You shouldn't be using that as your biggest value prop to come to your place. Like at this point, it's 2025, right? So we've already gone through several $1 billion of hacks and learned enough lessons. I mean, yes, it's also always nice to teach the new crop coming into crypto their lesson before they graduate, receive their graduation certificate. But maybe we are past that. So
I lost my life savings again. It's like that's the.
But you get to lose your life savings. You get to lose your life savings.
Now you're a native.
You get to lose your life savings too.
So you get a pull out.
Welcome. So no, maybe let's not do that.
Yeah.
So in this case, I'm like, let's just build the infra that allows these exchanges to just work without even thinking about that, right? It should just be a part of your stack by default, right? So you don't think about whether to use cloud computing or host your own servers or something like that. You're building a native, mobile app or anything else. So why think about, like, there's a certain set of standard best practices that you always account for when you're building an application. And ZK and provability should just be a default, or you shouldn't have to think about that.
Exactly. And I guess a follow-up question to that, do you see that as you're building Exchange OS, exchanges will want to come in and essentially prove your assets? Will there be like a status quo within exchanges that we see today where provability is a core product offering to reduce that requirement of trust, essentially?
No, for sure. I think like many exchanges already do proof of reserves, right? So Bybit does it, Binance, all these. I think Nick Carter talks about the rate, rating exchanges based on their proof of reserves. So that's already a thing, right? It's been happening for quite a few years. Proof of solvency is the next evolution in this best practice. Obviously, today it's hard for any exchange to just publish that because you can't just publish proof of solvency without disclosing user data, like particularly user balances, and no user wants that, right? So, I mean, yes, people think we need transparency, but that's the issue with running a fully on-chain order book as well, that it makes everything transparent. Maybe things that you don't want to be transparent, right? So, like, I don't want my friends or anyone else to know that I paid for you guys' dinner tonight. So maybe, yeah. So I would like that to be private. So same thing, right? So which is also the reason why it becomes a little more tricky to publish that information, and which is why many exchanges haven't done that yet. And then for them to switch to a very new experimental stack like ZK to start proving solvency is like a tough thing to do, right? Because if you have like 10 years of tech debt that you've accumulated, all of a sudden, hey, just switch to a new thing. Just with all the hierarchy and other things they're dealing with, it's really hard. So, which is why the only way to do this is to build this from ground up, right? So with first principles, from the foundation level, it's built in, which is Hibachi is what we're doing, right? So you're building that with ZK is built in. And then obviously, eventually, fingers crossed, if Hibachi becomes one of the mainstream success stories that everyone is using, and one of the key things that people like about it is the proof of solvency, then that does create a forcing function for other competitors to start doing that, because then they're like, wait a minute, we see a threat, and they do this, and maybe we need to adhere to that stack, right? So which is why a key thing here was not just publish XOS, but also work with Hibachi to build an exchange that does offer you proof of solvency and shows how the ZK thing works in practice, right? Let the users kind of feel it, because for the longest time, ZK was this little magic trick that, only if you're like a cryptographer or a scientist, you kind of appreciate what it does. But then if you're a commoner, right, you don't really, like, okay, cool, ZK, but what does that even mean, right? So, and in this case, you finally get to see and experience that in action, and you're like, oh, wait a minute, this is actually pretty neat, right? So, and that's what this is, right? It's finally 2025, the year of ZK, the future is provable, right? So that's where we are.
I love that direction, taking ZK, putting it into a real use case, and then essentially building for user adoption UX. I think that's where what we're building becomes real, right? We're building a real product that serves real needs, and just abstracting away that complexity into the specific targeted use case. So really appreciate that with that explanation. So I guess tell me a little bit more about like the data availability. So I know that you're looking at data availability expansion to Celestia, and you're thinking of utilizing RISC-Zero's ZKVM. Can you tell me more about that sort of integration? Like what are you seeing to benefit from adding, I guess, more of these different data layers?
Yeah, so RISC-Zero ZKVM allows us to basically compute proofs, right? So what we built is basically a bunch of Rust binaries that allow you to prove exchange-specific operations. We started with perps, we're adding spot, multi-collateral, all these things. And then almost think of RISC-Zero as AWS, or succinct prover, SP1, whatnot. So they are essentially offering you infra to run your proving logic and generate proofs that you can post to respective chains, right? So they provide that infra. And then Celestia, but now obviously you can have a proof, right? But then how do you know that this proof was in fact generated using right set of inputs? Maybe I just used my birthday party invitation as a way to generate the proof. You have no way of knowing that, right? So you can say, like, yes, the computation is correct, but how do I know that I really use the right set of inputs to compute that, right? So that's kind of where you need a DA, right? So now the problem is if you just publish inputs, that discloses user information again, right? So you don't want that. So what we are in the midst of doing at the moment is build this privacy layer that allows us to post encrypted data on any public DA, let it be Celestia or anything else, right? So, and then we want to build this way. Right now there's few ways of doing it, right? We can obviously, one simple way we're thinking of doing is we can use T's, where basically there's a decryption key inside the T, and that essentially decrypts the encrypted data to generate attestation proof.
The trusted execution environment.
Correct.
For the audience.
Correct. So you can use that to basically validate that this encrypted data does map to the right set of inputs that resulted in the ZK proof that is sitting in the contracts, right? So obviously over time we can maybe even use ZK for that, but I think that's a good place to start with. So one of the things we're working on currently is the privacy layer to post encrypted data on the public DAs. Once we have that, then you have this full set of privacy preserving yet performant exchange where you can have like mathematical guarantees that it is solvent at any given time.
Amazing. I like the future directions, right? Integrating privacy with ZK capabilities, with that verifiability. I like the direction, essentially making people, essentially guaranteeing that you are solvent, and then you have the assets that are present. I think that's a core and key problem that we got burned with FTX, and I think we're learning to adopt more and more of these things. I guess we might be in that last final stretch. Do you have any final words, announcements, anything that you want the audience to take from this and maybe apply it into whatever that they're doing?
No, absolutely. So from ExchangeOS side, we are obviously, like I said, I think I already mentioned the encryption layer that is coming up. So that's the thing that's been worked on currently before the SDKs become open. So I think that's going to be a big milestone that's going to be up and coming product-wise. But just macro level, I think, like I've been saying, for years, ZK was seen as this research breakthrough that wasn't quite ready for production, right? So it was considered complex, expensive, hard to implement, but that is no longer true, right? So it's the year's 2025, and I think ZK is finally fast enough, it's mature enough to be basically the backbone of real-world applications, right? And we're not just talking about theoretical experiments. If we're talking about production-ready code that is already, like I said, Hibachi is a great use case, right? By showing how it can be experienced, right? So that's why we're saying, the future isn't just decentralized; it is provable, right?
Mm-hmm.
So.
Yeah, I would just say it seems to me like people are catching on. It's often that I see kind of somebody mention like, "Hey, the next Hyperliquid is a ZK Hyperliquid, right?" Those are not even things that we're saying. We're in an environment right now where we're actually just starting to talk about this. So in that sense, it's a very exciting time for us, right? Because we've been working towards this for quite some time. And so I think stars are aligning a little bit, honestly, because people are looking externally again for the future of exchanges, and we're just getting out of a beta now and starting to really kind of showcase the tech and the exchange to the world. And I would say, I think come and try it out, because it's only going to get better from here. There's a very extensive roadmap that we'll share in due time. But again, I think one of the key components of our conversation today for me was also that very frank reminder that we're building an exchange for the end user, right? So yes, ZK allows us to do that, but day to day, like we were talking about earlier, we're thinking about liquidity, we're thinking about markets, we're thinking about having a really, really good just overall trading experience that's performant and has that proof of solvency component to it. So exciting times, and excited to keep, kind of building up all these different things, and lots to come.
Amazing. Thank you so much, Thibault and Varun. Your input to the space and your descriptions of the practical applications of this technology. I think very inspiring, and I hope to see many more applications like yours be part of this.
I was going to say, go to hibachi.xyz and try it out.
Yeah.
I think that's, obviously there's some new alpha that will be announced in the coming weeks, but if you're trying right now, you will be early.
Yeah.
And you'll be rewarded for being early. So
Amazing.
Won't say how, but yes.
There's ways to prove that.
There's provability in that.
It's provable.
Awesome. Thank you guys for coming, and
Thank you.
Awesome.